It is given to us by the question that the sum of the first four terms of this geometric progression, so S4, this is given to us as 0, which means that the first term, which is f, the common ratio, which is r to the power of 4, first sum of the first four terms, this is equal to 0, which means that we will end up with an equation f of 1 minus r to the power of 4. This is equal to 0. Since it is given to us that f, the first term, cannot be equal to 0, this tells us that 1 minus r to the power of 4 got to be the one that is equal to 0, which means that r, solving this, can be either minus 1 or r can be equal to 1. But for a geometric progression, r cannot be equal to 1, or else every single term will just be the first term, the first term, the first term. We will not see the geometric progression pattern. So 1, it is going to be rejected, which means that r has to be equal to minus 1. And as for the first term f will still remain as every possible real numbers except 0. So if we were to really be required to state a pair of values for f and r, I can go for f to be any numbers other than 0. So for example, I can go for f to be equal to 5 and r will be equal to minus 1. Or we can also go for f to be, let's say, 7, then r to be equal to minus 1, and so on. There are a lot of different pairs of values for f and r, as long as r is equal to minus 1 and as long as f is not equal to 0. And according to the question, we are supposed to find the sum of the first n terms in terms of f. So the sum of the first n terms in terms of f, the sum of the first n terms, Sn. So the sum of the first n terms, it will be the first term, f, then 1 minus the common ratio. Common ratio in this case is minus 1 all the time. So minus 1 to the power of n divided by 1 minus minus 1. So the sum of the first n terms will be half of f of 1 minus minus 1 to the power of n. We are supposed to express the sum in terms of f. So we need to find a way to reduce this negative 1 to the power of n so that the entire Sn is going to be expressed in terms of f. So negative 1 to a power of n, and n is an integer number, which means that n can be even or odd. And this will make it easy for us to decide, right? Because negative 1 to the power of an even number is going to be 1. So if it is 1 minus 1, we're going to be getting a 0, which is actually supported here as 4 is equal to 0. So if n is an even number, for example 2k, if n is an even number, we will have a 1 minus 1, which is 0. So one of the possible s is 0. Another possible one is, of course, when n is an odd number, for example 3. Minus 1 to the power of 3 is going to be still minus 1, which means that we will be getting something that is like half f of 1 minus minus 1, which will give us a half of f of 2. So it is going to give us f, which means that another possible value, another possible expression for Sn in terms of f will be just simply f.